For my second project, I decided to do marginal propensity to consume. In this presentation, we're going to go through first what exactly marginal propensity to consume is, and then we'll determine how it is calculated. We will determine what the required calculus is in order to solve such problems involving marginal propensity to consume. We'll have an example and a more basic example, and then we'll have a example that involves a tax, so it's more involved, and then a summary and closing. So first of all, marginal propensity to consume is defined as a proportion of an aggregate raise in pay that a consumer spends on the consumption of goods and services as opposed to saving it. So on a more basic level, if a consumer gets a boost in income, a marginal propensity to consume represents the amount of the boost the consumer will spend compared to the amount they will save. So for example, if I had a marginal propensity to consume of 0.6, that means I would spend 60 cents or 60% of every additional dollar that I came across. The equation for marginal propensity to consume is a change in consumption over a change in disposable income that produced the consumption. So in reality, it is actually a derivative as it is a change in function. And then another example, a more concrete example, let's say I work at the job I work at, I got a $1,000 bonus, and I decided to spend $250 of that on a new pair of running shoes and then save the rest of it. My marginal propensity to consume would then be the change in consumption, which is 250 divided by the change in income, which is 1,000, to get 0.25 or 25%. So the calculus that we are going to need in order to solve this is a geometric series. So we all know that a equation for the geometric series is the summation of n equals 0 to infinity of a times r to the n, where a is the beginning value and r is the common ratio. And we all know that we get r by doing a sub n plus 1 over a sub n. And then, of course, if the absolute value of r is less than 1, the series will converge, and it will converge to a over 1 minus r. However, if r is greater or equal to 1, the series will diverge. However, in the MPC problems, we can never have a r value that is greater than 1, as people cannot technically consume more than they receive. However, obviously, in reality, they do. But in the scope of these problems, we will just focus on r values less than 1. So the series will always converge. All right, so for our first example, we have a marginal propensity to consume of 0.6, and we need to determine the total amount of money that the economy will eventually pay or spend. So if person 1 has $1,000, they are going to consume they're going to spend 0.6 of that, or $600. So then the person 2 ends up getting $600 of the original $1,000 additional funds. And this will continue into person 3. So person 3 gets $1,000 times the original 0.6 times another 0.6 that the person 2 pays, because the whole economy has an MPC of 0.6, not just one person. So every time another person spends, another 0.6 is multiplied upon. So then by the time the money gets to the 5th person, it's the original $1,000 times 0.6 to the 4th. And then so the 6th person would receive $129.6 of additional income. So we can look at it as the total output for the economy would be 1,000 plus 1,000 times 0.6 to the first, plus 1,000 times 0.6 to the second, plus 1,000 times 0.6 to the third, and so on. And as we know, this is geometric series that can be rewritten as the summation of n equals 0 to infinity of 1,000 times 0.6 to the n, with 1,000 being the initial term and 0.6 being the ratio. So despite being able to already know that the ratio would be 0.6, we did go ahead and solve it up here. So a sub n plus 1 over a sub n equals the 1,000 times 0.6 to the n plus 1 over 1,000 times 0.6 to the n, which would equal 0.6. So as 0.6 is less than 1, the summation of n equals 0 to infinity of 1,000 times 0.6 to the n is a geometric series that converges to a over 1 minus r, or 1,000 over 1 minus 0.6, which is 2,500. So in this example economy, they will spend an additional $2,500 when a 1,000 additional is provided due to the MPC of 0.6. For our next example, we need to know that economists do not generally use the mathematical variables of a and r. Instead, the initial term a is represented as x, and then the r ratio is represented as an abbreviation of MPC. All right, so for our tax example, we want to determine what will happen when taxes are taken into consideration. So if a tax is imposed, what is effect on total expenditure? So as we know before, without tax, it is just the initial term times the MPC to the nth power. However, a change in tax represents the amount lost due to the tax. So the consumer will now spend the delta t times MPC less. So this value will represent the new x, or the new first term. So in other words, x is now negative delta t times MPC. And rewriting a over 1 minus r in economic terms, as we learned from the last slide, we get x times 1 over 1 minus MPC. And then accounting for the tax, we can substitute x for negative delta t MPC and eventually get delta t times negative MPC over 1 minus MPC. And so this equation right there is the tax multiplier. When we plug in and solve, we are able to determine how much the tax causes the total expenditure to decrease by. So assuming a $250 tax is imposed and the MPC is 0.35, with excess money being $1,000, find its effects. So first, we want to use the tax multiplier in order to determine how much less money the tax will be causing the economy to spend. And so delta T of 250 times the negative MPC of negative 0.35 over 1 minus MPC of 1 minus 0.35, and you eventually get negative $134.62. And then we want to use the other equation that we learned before, just the normal multiplier, in order to get $1,538.46 of total expenditure. And then the total expenditure minus the value we got from the tax multiplier, we end up getting an actual total expenditure of $1,403.84 when taking taxes into account. So in summary, the marginal propensity to consume expresses the percentage of additional income a consumer is willing to spend. This can be illustrated as a converging geometric series with an R value equaling the MPC value and the total expenditure equaling the beginning value divided by 1 minus MPC. When taxes are taken into account, the total expenditure must be offset by a tax multiplier, which is the negative of the MPC divided by 1 minus MPC. This multiplier is then multiplied by the beginning value to come up with the total amount of taxes taken away. Thank you.